So again the contour integration, that is evaluation of the real integral. The evaluation of the real integral, the evaluation of the certain types of the real definite integrals of the complex function over the suitable closed paths or contours, and applying the Cauchy residue theorem is known as the contour integration. And the first of all, type 1 integration around the unit circle. So integral of the type 0 to 2 pi the function of cos theta as sin theta into d theta, that is where f is the rational function in cos theta and sin theta. So to evaluate this type of integral, just take the unit circle mod z equal to 1 as the contour. So integral of 0 to 2 pi, the limit is very important. Function of cos theta sin theta. So f is the rational function in cos theta and sin theta, that is. And to evaluate these integrals, we take the unit circle mod z equal to 1 as the contour C. So on mod z equal to 1, z equal to e power I theta. So from this dz by d theta equal to I e power I theta. E power I theta is z, so I is it. So d theta equal to dz by I is it. Okay. So then from this cos theta equal to e power I theta plus e power minus I theta divided by 2. So that means z plus 1 by z divided by 2, that is z square plus 1 divided by 2z. The same way sin theta equal to e power I theta minus e power minus I theta divided by 2i. So from this z minus 1 by z, e power I theta is the z, e power minus I theta is 1 by z. So z square minus 1 divided by 2i z for the sin theta. So when you replace in the problem f of cos theta sin theta, the rational function substitute panningina in the denominator. So the problem is become function of z square plus 1 divided by 2z, z square minus 1 divided by 2iz into dz by iz. So in the problem total in terms of z la irukku. Now applying the Cauchy residue theorem, so we can evaluate the integral on the right hand side. So Cauchy residue theorem means integral c, this one equal to 2 pi I into sum of the residue. Sum of residue at each of its poles. This is called the residue theorem. And evaluate the something using the contour integration. Just replace z equal to this is the procedure. Dz equal to e power I theta, d theta equal to dz by iz, sin theta equal to z square minus 1 divided by 2iz. இதை இங்க replace பண்ணா problem total என்ன ஆகும்? That is in terms of z ல மாறிடும். Total z ல மாறின பிறகு actually நீங்க Cauchy residue theorem apply பண்ணலாம். So just cross multiply LCM எடுத்துட்டு இந்த 2iz மேலே போயிடும், இந்த iz கேன்சல் பண்ணலாம். ஓகே, ஸோ இங்கே ஒரு 2 இங்கே வந்து கேன்சல் ஆகிடுது, that is 2 2s are 4. So then it's become the Cauchy residue in terms of z, function of z. So we can apply the Cauchy residue theorem for this one. Cauchy residue theorem 2 pi into sum of the residue at each of its poles. Function வந்து இந்த மாதிரி ரேஷனல் ஃபங்க்ஷனாக தான் இருக்கும். ஸோ தட் டினாமினேட்டர் ஜீரோக்கு ஈக்குவல் பண்ணால் வி கெட் த போல்ஸ். ஸோ இங்கே வந்து பார்த்தீங்கன்னா டினாமினேட்டர் ஜீரோக்கு ஃபேக்டரைஸ் பண்ண முடியல. ஸோ just using the formula minus b plus or minus root of b square minus 4ac divided by 2a. So minus 5i plus or minus 3i divided by 4. So இதை சிம்பிளி பண்ணிங்கன்னா இங்கே ரூட்டுக்குள்ளே மைனஸ் வர்றதுனால ஐ வருது. ஸோ சம் பண்ணி இல்லை சப்ராக்ட் பண்ணிங்கன்னா we get that minus I by 2 minus 2i. These are poles of order 1. ரெண்டுமே வந்து poles of order 1. So that is mod z equal to 1 என்றது contour integral. So z equal to minus I by 2 போடும்போது modulus of minus I by 2 na, that is called plus 1 by 2 வந்துரும். 1 by 2 என்றது less than 1, 1 விட சின்னது அப்படின்னா inside. And z equal to minus 2i போடும்போது modulus of minus 2i னா that is called the 2 இல்லையா, வெறும் minus 2i இருக்கிறதுனால 2ன்றது greater than 1, that is called the outside. ஸோ நீங்கள் டயக்ராம் போடாமல் இது மாதிரி அதை என்ன கொடுத்துருக்காங்களோ கர்வு அதை பேஸ் பண்ணி கூட போடலாம். இந்த 0 to 2π உள்ள ஃபங்க்ஷன் ஆஃப் காஸ் தீட்டா சைன் தீட்டா இருந்ததுன்னா தட் இஸ் டெஃபினட்டாக மாட் இஸ் equal to 1 தான். அது 0 to 2π இந்த இன்டர்வல் உள்ள வந்து ஃபங்க்ஷன் ஆஃப் காஸ் தீட்டா சைன் தீட்டா இல்லை காஸ் டி சைன் டி காஸ் எக்ஸ் சைன் எக்ஸ், ஓகே, இன் டர்ம்ஸ் ஆஃப், பட் இது லிமிட் வந்து 0 to 2π இருக்கணும், இல்லை 0 to π இருக்கலாம். 0 to π இருந்தால் we can convert to 0 to 2π. So we can find out the residue only for the minus I by 2. So residue minus I by 2, it's a simple pole. So residue at the point z equal to minus I by 2, limit z tends to minus I by 2, z plus I by 2 into f of z. F of z is here 1 by 2 into z plus I by 2, z plus 2i. So the z plus I by 2 கண்டிப்பா cancel ஆயிடுச்சு. So and then limit equal to z க்கு பதிலா I minus I by 2 போட்டீங்கன்னா else விடுது சப்ளை பண்ணினா we get that 4i minus I, that is called 3i. 3i by 2 by 2 by 2 cancel ஆயிடுச்சுன்னா then 1 by 3i. So when you apply the Cauchy residue theorem, that is 2 pi I into 1 by 3i, so I cancellation, that is called the 2 pi by 3 is the answer. So like this, it's a very simple problem. ரொம்ப கேட்டாங்கன்னா in cases ரொம்ப சிம்பிளா like that இது மாதிரி தான் கேட்க முடியும். ஸோ ரொம்ப லென்த்தியாக கேட்க முடியாது. ஸோ e power I theta d theta equal to iz. ஸோ இங்கே பார்த்தீங்கன்னா sin theta equal to the something the same way like that previous problem. The 0 to 2 pi d theta by a plus b cos theta in general, that is z equal to e power I theta. ஸோ ரொம்ப முக்கியமான விஷயம், இந்த கான்டூர் வந்து கன்வெர்ட் பண்ணுறதுக்கு mod z equal to 1 யூஸ் பண்ணுறோம், that is very important. ஓகே, பேசிக்காக கேட்கக்கூடிய கொஸ்டின். And then for the mod z equal to 1 என்ன transformation பண்ணுறோம், that is z equal to e power I theta and d theta equal to dz by iz. ஸோ இதனுடைய டிரான்ஸ்மிஷன் என்னவா மாறுது, இதனுடைய கரஸ்பாண்டிங் கான்டூர் இன்டெக்ரல் என்ன, ஓகே, அட்லீஸ்ட் இந்த போர்ஷன் கேட்கலாம். அதனுடைய கரஸ்பாண்டிங் கான்டூர் இன்டெக்ரல் என்னன்னு, ஸோ f of z equal to bz square by something. ஸோ இங்கே பார்த்தீங்கன்னா மைனஸ் ஏ ப்ளஸ் இங்கே ஏ கிரேட்டர் தன் 0 பி கிரேட்டர் தன் 0 கொடுத்துருக்காங்க. ஸோ ஃப்ரம் திஸ் ஐடியா, ஸோ மாட் ஆல்ஃபான்றது பார்த்தீங்கன்னா mod beta, that is called mod alpha is less than 1, mod beta is greater than 1 because of a greater than b, a greater than b, and alpha lies inside, beta is lies outside. So then b square, b z square something now, that is called b into z minus alpha, z minus beta, like that இதை factorize பண்ணணும். ஸோ z equal to alpha insideன்றதுனால z equal to alpha மட்டும் ரெசிடியூ கண்டுபிடிச்சிட்டு and then alpha beta substitute பண்ணீங்கன்னா we get the root of a square minus b square. So integral c, integral 0 to 2 pi d theta by a plus b cos theta, that is 2 by 8, 2 pi I into something, so they simply putting up pi I by something, so that pi I by root of a square minus b square. What is the problem? Yeah, இங்கே 2 by I into something இருக்குது, integral c f of z dz எடுத்துக்கோ. ஸோ 2 by I into இதனுடைய கரஸ்பாண்டிங் வேல்யூ, இதனுடைய வேல்யூ தான் ஃபைண்ட் அவுட் பண்ணியிருக்கோம், தட் இஸ் 2 pi by so 2 pi by root of a square minus b square. So இதை கொஞ்சம் மெமரைஸ் கூட பண்ணலாம். So value of this integral 0 to 2 pi d theta by a plus b cos theta is nothing but the 2 pi by root of a square minus b square. And the same way, integral 0 to 2 pi d theta by 1 minus 2p cos theta plus p square, that is 2 pi by 1 minus p square in the case of mod p less than 1. So that is the same procedure. So pz square plus minus of 1 plus p square into z plus p. So dz by iz, that is z cancel ஆச்சுன்னா 1 by I வெளியே எடுத்துட்டீங்கன்னா that is z square term. So that is minus by pz square இருக்கிறதுனால மைனஸை வெளியே எடுத்தீங்கன்னா minus 1 by I into the something result. So minus 1 by I into the that is pz square minus of 1 plus p square into z plus p என்றதை 0 க்கு get பண்ணீங்கன்னா we get it z equal to like this p square plus 1 whole square minus 4p square that is இதில் ஒரு 2p square இதில் ஒரு minus 4p square. So p square minus 2p square plus 1 ன்னு வரும், that is p square minus 1 whole square. So the square root எடுத்தீங்கன்னா that is p square minus 1. So this step very important. So then when you simplify it, p square plus 1 plus p square minus 1, p square plus 1 minus p square minus 1, so whole divided by p. So the p and 1 by p, these are force. Mod p less than 1, that is given. So z equal to p என்றது that is lies inside of the mod z equal to 1, and z equal to 1 by p is the light side because of mod z equal to 1. So mod p என்றது less than 1 என்றதுனால, so z equal to p க்கு மட்டும் ரெசிடியூ கண்டுபிடிப்போம். So நம்ம ஃபேக்டரைஸ் பண்ணுறது பார்த்தீங்கன்னா p இன்ட்டுன்னு எழுதணும் because of pz ஸ்கொயர் வரதுனால, that is very important. இதை ஸ்கிப் பண்ணுறதுக்கு மறந்துடுறதுக்கு ஞாபகம் இருக்கு. So that is p square minus 1 divided by p cancel ஆச்சுன்னா 1 by p square minus 1. So therefore that is the 2 pi into sum of the residues, 2 pi into 1 by p square minus 1. So when you substitute here we get the result. So the same procedure. Okay, but in the cos 3 theta something வரும்பொழுது numeratorல that is the real part of z cube, that is z equal to e power I theta. So that is z cube equal to e power I 3 theta, that is cos 3 theta plus I sin 3 theta, z cube equal to, so that is real part of z cube for the cos 3 theta. Numeratorல வரதுக்கு real part of, இங்க sin 3 theta வந்துனா imaginary part of z cube. So real part of something வந்துரும், and then real part of final answer கண்டுபிடிச்சு அதில் இருக்கிற real part மட்டும் எடுத்துக்கணும். Okay, this is the function z cube by something. So numerator trigonometric function sin cos வந்ததுன்னா in terms of real part இல்ல imaginary part of the something exponential function. So final கிடைக்கிற answerல just take real part. இங்க பார்த்தீங்கன்னா I cancel அடிச்சோன்னா ஃபுல்லாக இருக்கிறதே real part தான். So that pi by 12. So இதே மாதிரி sin square theta வந்திருக்கு. sin square thetaன்றது 1 minus cos 2 theta whole divided by 2. Numeratorல denominatorல as usual procedure, that is cos theta equal to z square plus 1 divided by 2z. So then z equal to e power I theta, d theta equal to dz by iz, cos theta equal to z square plus 1 for the denominator. For the numerator மட்டும் that is 1 minus cos 2 theta whole divided by 2, and then cos 2 theta என்றது real part of z square. So then 1 minus real part of z square. So this is dz, 5 minus 3 into something iz whole divided by 2 by 2. That is when you simplify it, this is the result, minus 1 by I. And then residue கண்டுபிடிச்சு which is belongs to lies inside. இங்க வந்து unit circle. Unit circle is the contour. அதை மைண்டில் வச்சுட்டு when you substitute z equal to 1 by 3 here, 1 by 3 is less than 1, z equal to 3 என்றது outside, so 1 by 3 க்கு மட்டும் residue கண்டுபிடிப்போம். So 1 by 3 க்கு residue that is z minus 1 by 3 into the something 3 into எழுதுவோம், so that we get that minus 1 by 9. So residue theorem apply பண்ணினா 2 pi into something, so that இதில் இருக்கிற ரியல் பார்ட் மட்டும் கலெக்ட் பண்ணோம். ஸோ தட் இஸ் த 2π/9. So using the contour in the same way, the real integral, the numerator இருக்கிறதுக்கு real part of something போடலாம், denominatorக்கு z square plus 1 divided by 2z. ஸோ உங்களுக்கு டிஸ்கிரிப்டிவ் டைப் இருந்ததுன்னா கண்டிப்பாக இதில் இருந்து ஒரு கொஸ்டின் கேட்டிருப்பாங்க. ஸோ மேபி லைக் தட் இது மாதிரி சிம்பிள் ப்ராப்ளம் கேட்கலாம், ரொம்ப டிஃபிகல்ட்டாக இல்லாமல் லைக் தட் சிம்பிள் ப்ராப்ளம் கேட்கலாம். இல்லை ஏபியில் வர மாதிரி ஸ்டாண்டர்ட் ஃபார்மில் கேட்கலாம். இன் டர்ம்ஸ் ஆஃப் a plus b cos theta denominator இருந்ததுன்னா how to express தான். இது மாதிரி தானே இன்டெகிரேஷன் அரவுண்ட் த செமி சர்க்குலர் கேண்டூர் is the type 2 integral minus infinity to infinity f of x divided by g of x dx. Now f of x and g of x are the polynomial in x such that the degree of f of x is less than that g of x, less than that g of x at least by 2. G of x doesn't vanish for any real x. So in the case of the f of x by g of x, the limit is minus infinity infinity form is called the second type, and that is integral around the semicircular contour. So the degree of the f of x is less than degree of the g of x at least by 2, and g of x doesn't vanish for the any real x. That is the condition. So CB closed contour consisting of the real axis, that is minus r to r, and semicircle s. Sometime gamma கூட யூஸ் பண்ணலாம். semicircular s, that is called of radius capital R above the real axis, above the real axis. Then integral c into the integral minus r to r f of x by g of x dx plus integral c f of z divided by g of z dz. When r is approaches to infinity, this is the semicircular region, and that is minus r to r. When r is approaches to infinity, then it's become, okay, when r is approaches to infinity, integral c, the curve is, this is called the curve, this is s என்றது. So then r is approaches to infinity, integral s f of z divided by g of z dz approaches to 0. So that because of the reason பார்த்தீங்கன்னா, this as r is approaches to infinity, this is extend to here. So then curve, no curve here. The curve is become the curve portion, integral f of z dz equal to approaches to 0. Okay. r into the approach, r into the infinity approach பண்ணும்போது இதை எக்ஸ்டெண்ட் பண்ணுறீங்கன்னு நினச்சிக்கோங்க, இந்த கர்வே காணாமல் போயிடும். தட் இஸ் integral s f of z dz, f of z by g of z dz equal to approaches to 0. அப்படின்னா என்ன ஆகும்னா, r is approaches to infinity, integral c f of z dz f of z divided by g of z dz equal to integral minus infinity infinity f of x by g of x dx. So that is called the Cauchy-Riemann theorem. And Cauchy lemma பார்த்தீங்கன்னா f of z is continuous, and modulus of z f of z dz, modulus of z f of z approaches to 0 uniformly as mod z approaches to infinity. And yes, so integral s f of z dz approaches to 0 as r tends to infinity. Okay, this is called the Cauchy lemma. And the contrary is integral minus infinity to infinity x square dx divided by x square plus a square x square plus b square, a greater than b greater than 0. So that just replace x by z, dx equal to dz. This is the problem. Integral c f of z dz. So how to express the c here? C is contour. C is the upper semicircular contour. That is f of z equal to something. So then pole கண்டுபிடிச்சோம்னா denominator 0 க்கு equal பண்ணா we get the pole. So that is upper portionல எதெல்லாம் இருக்கும்னா, the imaginary part பாசிட்டிவாக இருக்கிறதெல்லாம் இருக்கும். So z equal to ai and z equal to bi. The case of a greater than 0, b greater than 0, these are lies inside. Okay, 1 minus 3a into the outside because of negative part. 1 minus 3a into the 1 plus 3a into the inside. Okay, minus 7 plus 4a into the inside, like that. Okay, இது இன்சைடில் இருக்கும். ஸோ தட் z equal to ai ba இன்றது inside the upper plane. So only try to find out the residue for the z equal to ai and z equal to bi. So that is the limit z tends to ai, z minus ai, z square by something. So இதை factorize பண்ணீங்கன்னா z plus a into z minus a cancel பண்ணிட்டு, and then when you replace it, a by 2i into a square minus b square. So the same way for the z equal to bi. So இதை factorize பண்ணுவோம், that is z minus bi into z plus bi, z minus bi z plus bi ன்னு வந்துடும். Just replace z tends to bi, so then we get b by 2i into a square minus b square minus b by. So the same way, the Cauchy residue theorem, 2 pi into sum of the residue, and then take the LCM, then when you simplify it, so pi by a plus b is the answer. So when you apply the Cauchy lemma, that is integral minus infinity to infinity, the x square pi by a plus b. So the result of is standard கொஞ்சம் ஞாபகம் வச்சுக்கலாம், that is லென்த்தியாக போட முடியாது. that is integral minus infinity to infinity x square dx divided by x square plus a square x square plus b square, that is pi by a plus b. So for the 0 to infinity வரும்போது, that is integrand is even, that is 0 to infinity 1 by 2 integral minus infinity to infinity எழுதலாம். இதனுடைய வேல்யூ pi by dx by x square plus a square or x square plus b square, so that is pi by a plus b. So 1 by 2 into pi by a plus b ன்னு வந்துடும். இதுக்கு தான் வேல்யூ எவாலுவேட் பண்ண முடியும் for the semicircular region. So pi by ab into, that is pi by 2ab into, that is a plus b. We thought is it correct? So z tends to ai, that is ai plus ai 2i ai. This is the a square, that is a square I square, that is minus a square. This is minus a square. Okay, so a cancel அடிச்சுன்னா, that is minus a divided by 2i into a square minus b square, correct one. It is minus b by something. So that you get 2 pi I by 2i, so a by a square minus b square minus b by, so this is a minus b, so pi by a plus b is correct one. Okay, correct. So this is x square dx, sorry, a little bit confused. Okay, correct. So pi by 2ab into a plus b. Okay. So the same way, integral minus infinity infinity dx by x square plus a square. So the same way, when you try to find out the z equal to plus or minus a is the lies inside only, because of the semicircular region. So residue of f of z is equal to a, limit z tends to a, z minus a into something. So 1 by 2ai. So this is equal to pi by a. So the value of this integral, that is pi by a. The value of an வச்சுக்கலாம். So integral minus infinity infinity dx by x square plus a square is the pi by a. So the x square plus a square na the pole of order 2 னு வரும் இந்த இடத்துல. So z equal to ai இன்றது is a pole of order 2 னு, that is d by dz z minus ai whole square into f of z. So then z minus a whole square cancel ஆயிடுச்சுன்னா 1 by z plus a whole square. So we want differentiate it and then substitute the z tends to a. இதை differentiate பண்ணீங்கன்னா minus 2 by z plus a whole cube. Then z equal to a னா minus 2 by 2a whole cube. That is minus 8a cube I. So then 1 by 4a cube and 2 pi into something na, then pi by 2a cube. So that is the value of this integral. So pi by 2a cube. Okay. So the same way this integral x square z power 4 something na, இதை factorize பண்ணீங்கன்னா z square plus 1 into z square plus 9, then z equal to plus or minus I plus or minus 3i. Only I and 3i are lies inside. So when you try to find out the residue at the point z equal to I and z equal to 3i, you get this one. So integral C f of z dz equal to 2 pi I into sum of the residue. So 2 pi I into LCM எடுத்தீங்கன்னா, then when you simplify it 10 by 48i. So I cancellation 5 pi by 12. So that is answer. And integral 0 to infinity x power 4 plus a power 4. So then this is 0 to infinity na, that is the 1 by 2 into minus infinity to infinity dx by x square plus b square. We can find out the value for this integral only. So in the integral evaluate பண்ணீங்கன்னா, that is z power 4 plus a power 4 equal to 0 na, minus a power 4. That is z equal to a power 4 e power I pi into 1 plus 2k. That is 2k pi plus pi. 2k pi plus pi. 2k pi plus pi whole divided by 4. That is a into z equal to a into e power I 2k pi plus pi whole divided by 4. So for the k equal to 0, 1, 2, 3 and so on. So therefore the values for e power a e power I pi by 4, a e power 3a I pi by 4, a e power 5 I pi by 4 when you replace k equal to 0, 1, 2, 3. So that is the fourth root of value, that is. So minus a power 4 z equal to a power 4 into minus 1 whole power 1 by 4. The minus 1 would be polar form e power I pi. I pi na, that is cos pi plus I sin pi. So then we can add the 2k pi. So whole power 1 by 4. That is idea. So k equal to 0, 1, 2, 3. இதில் எது lies inside the upper of plane la, a e power I pi by 4, a e power 3i pi by 4. These are lies inside. So and then when you substitute here, direct நம்ம எவ்வளவு பண்ண முடியாது. So then we can apply the L'Hopital rule. L'Hopital rule apply பண்ணி அப்படியே substitute பண்ணீங்கன்னா மேலே 0 கீழும் 0 ஆயிடும். ஏன்னா இதனுடைய ஃபேக்டர் அது. இதனுடைய ஃபேக்டர் தான், ஒன் ஆஃப் த ஃபேக்டர் தான் இது. ஸோ அதனால தட் இஸ் L'Hopital ரூல் அப்ளை பண்ணீங்கன்னா மேலே 1 ஆகிடும், கீழே 4z cube. அதில் இசட்டுக்கு பதிலாக இதை ரீப்ளேஸ் பண்ணீங்கன்னா we get the result. So z equal to a e power I 3a pi by 4. So then z minus something 1 by z power 4. So the L'Hopital rule apply பண்ணீங்கன்னா 1 by 4 z cube. Then once again when you substitute here we get the result. So by the sum of the residue, Cauchy residue theorem, 2 pi into sum of the residue. So ரெண்டுத்தையும் add பண்ணீங்கன்னா when you simplify it, e power minus 3i pi by 4, e power minus I pi by 4. So e power minus I pi, e power I pi by 4 எழுதலாம். So e power I pi value வந்து minus 1. E power minus I pi is cos of minus pi plus I sin of minus pi. That is always minus 1. So that is minus e power I pi by 4. So ரெண்டுத்தையும் add பண்ணீங்கன்னா that is called the minus 2 cos pi by 4. That is 1 by root 2. This is the value. When you substitute 2 pi into something, so minus pi I by root 2a cube. It's a very simple problem like that. That is. So integral is a real and positive. That is likely the sign, the phase error, the above the calculation. The correct known as integral 0 to something is pi by 2 root 2a cube. That is. So that is same way minus infinity to infinity dx by x square plus 1 whole cube. So that is C is the upper semicircle. Then this is a pole of order 3. Pole of order 3 means we want to differentiate the 2 times 1 by 2 factorial limit z tends to I d square dz by square z minus I whole cube into something. So then 1 by z plus I by whole cube. Just differentiate 2 times. 1 by x cube na minus 3 by x power 4. So once again differentiate minus 4 by x power 5. So minus 4 into minus 3, that is equal to 12 by x power 5. So that is z plus I whole power 5. So just replace z equal to I here. So then 2I whole power 5. So 32I. So 3 by 16I. So Cauchy residue theorem 2 pi into something 3 pi by 8. So this is the same way integral involving the sin nx and cos nx. This is the type 3, the integral of the form f of x by g of x into sin nx into cos nx, like that. So write in the sin nx in terms of e power I nx, cos nx, sin nx and cos nx in terms of e power I nx. That means this is the imaginary part of e power I nx, this is the real part of e power I nx. So C is the closed contour consisting of the real axis and the upper semicircular region. And this is an example for that cos mx no real part of e power I mx and then real part divided by that is real part of 1 by 2 into இங்கே வந்து 0 to infinity கொடுத்துருக்காங்க. ஸோ 1 by 2 minus infinity infinity எடுத்துட்டு and then cos mx பதிலாக real part of e power imx. So real part of 1 by 2 integral c e power imx z divided by z square plus a square. When you replace x by z and then f of z equal to something. So we can find out the residue, sorry, pole, and the pole நோடைய order வந்து இங்கே வந்து 1 தான். So z equal to ai is a pole of order 1. So residue of f of z, that is z minus a into something. So that integral c f of z is 2 pi into some of the residue. So then we get the result. So integral 0 to infinity x into sin mx divided by x square plus a square dx na a greater than 0, m greater than 0. இது என்ன பண்ணோம், imaginary part of e power imx னு எடுத்துட்டு first of all இதை வந்து 1 by 2 minus infinity infinity convert பண்ணணும். So minus infinity infinity and then replace x by z, x equal to z ன்னு போட்டுட்டு and then e power imaginary part of e power imx. So imaginary part ன்றது கடைசி வரலி வரும் ப்ராப்ளத்தில். ஃபைனல் ஆன்சரில் just take the imaginary part. ஸோ இதனுடைய ரெசிடியூ கண்டுபிடிக்கிறது இட்ஸ் அ வெரி ஈஸி. ஸோ போல்ன்றது ஆர்டர் 1 தான், டிஃப்ரென்ஷியேஷனே வராது. ஸோ ஜஸ்ட் ஃபேக்டரைஸ் பண்ணிவிட்டு லிமிட் சப்ஸ்ட் பண்ணிவிட்டு கேல்குலேட் பண்ணுறது தான். அண்ட் தென் காஸ்ட் ரெசிடியூ தேரத்தில் அப்ளை பண்ண பிறகு ஸோ வி கெட் த ஜஸ்ட் டேக் த ஒன்லி ரியல் பார்ட். cos x வந்துடும். ஸோ ரியல் பார்ட் ஆஃப் e power ix minus infinity infinity தான். ஸோ இங்கே plus a and plus bi lies inside and then we can evaluate the integral value. So pi by ab into a square minus b square, a into e power minus b and minus b into e power minus e for this problem. முடிஞ்ச அளவுக்கு மெமரியில் வச்சு கொஞ்சம் ட்ரை பண்ணுங்க. Okay. And the next for topic பார்த்தீங்கன்னா maximum modulus principle. So the maximum modulus principle, if a function f is analytic and not constant in a given domain D, then modulus of f of z has no maximum value. Modulus of f of z has no maximum value in D. ஒரு ஃபங்க்ஷன் வந்து அனாலிட்டிக்காக இருக்குது, நாட் எ கான்ஸ்டன்ட் கிடையாது, அனாலிட்டிக்காக இருக்குது அப்படின்னா modulus of f of zன்றது has no maximum value in the domain D. That is, there is no point z not in the domain D such that mod of f of z less than or equal to mod of f of z not. இது மாதிரி ஒரு பாயிண்ட் டொமைன் Dல எக்ஸிஸ்ட் ஆகாது அப்படின்னு அர்த்தம். Okay, that is called the maximum modulus principle for all points z in D. The local maximum lemmaன்றது that is mod of f of z. Suppose mod of f of z less than or equal to mod of f of z not at each point z in some neighborhood of the z naught, that is mod of z minus z naught less than epsilon, some neighborhood of the z naught la, and mod of f of z less than or equal to mod of f of z naught for each at each point of the z, in which f is analytic. So then f of z as a constant value, f of z as a constant value, okay, f of z naught throughout that neighborhood, f of z as a constant value throughout that neighborhood, that is called the local maximum lemma. Okay, so the same way maximum on the boundary, suppose f is continuous on the closed bounded region R and it is analytic and the function is continuous on the closed boundary and the function is analytic and not constant in the interior of the region, then the maximum value of the mod f of z in R, which is always reached, occurs somewhere on the boundary of R, never in the interior. Okay, so the function is, that is called another function is continuous on the boundary, analytic and not constant in the interior. Okay, and the maximum value in R of the function mod f of z in R, which is always reached, occurs somewhere on the boundary of R. உள்ள வந்து அதுக்கு மேக்ஸிமம் இருக்காது, ஒன்லி பவுண்டரியில தான் அதுக்கு மேக்ஸிமம் ரீச் ஆகும். தட் இஸ் ஐடியா, மேக்ஸிமம் ஆன் த பவுண்டரி. ஓகே, ஸோ the எக்ஸாம்பிள் பார்த்தீங்கன்னா f of z equal to z plus 1 whole square, that is defined on the closed triangular region or and with vertices பார்த்தீங்கன்னா z equal to 0, z equal to 2 and z equal to I. So that means, so that is z equal to 0, that is 0, 2 ன்றது here and z equal to I ன்றது this is. So when I join this one, this is a closed region, triangular region. So this is a function defined on the closed region and some geometric argument can be used to locate the point in R, that is the boundary, yeah, at which the modulus of f of z has its maximum and minimum value. The argument is based on the interpretation of the mod of f of z as the square of the distance d between the -1 and any point z in the R. So the d square equal to, that is -1 under the here. So that is any point on the R under the region. So that is d square equal to mod of f of z, that is z minus of -1 whole square, that is z plus 1 whole square, that is the function given, that is f of z plus 1 whole square. So therefore the maximum and minimum value of d, okay, therefore the mod f of z occurs at the boundary point, that is z equal to 2 and z equal to 0 respectively. So the maximum value occurs at the point z equal to 2 and the minimum value occurs at the point z equal to 0 respectively. Am I correct? This is the point, some other point z equal to -1. So z equal to, that is the distance of the z equal to -1 to z equal to 2 is the maximum value and z equal to 0 ன்றது, that is called the minimum value. So that this example, the maximum on the modulus is the maximum occurs on the only boundary. Maximum occurs on the boundary. Okay. So the example sum in the Churchill book la, and Liouville's theorem, that is called if a function f is entire, that is means analytic everywhere in the C and bounded in the complex plane, then f of z is constant throughout the plane. Function is entire and bounded இருந்ததுன்னா, that is called the function is constant. That is a very important statement in the complex analysis, that is called the Liouville's theorem. So that means mod f of z is less than or equal to m for all z belongs to C. Fix any point z not belongs to C. Let r capital R greater than 0 by the Cauchy's estimate for the derivatives. Mod of f dash of z not less than or equal to m by r. So this is true for all r greater than 0. So let r tends to infinity, and that is f dash of z approaches to 0. So then z0 is arbitrary integral, f dash of z equal to 0. Therefore f is constant. Another very important fundamental theorem of algebra: any polynomial p of z of nth degree polynomial of degree n greater than or equal to 1 has at least one 0. As at least one 0. That means there exists at least one point z0 such that p of z0 equal to 0. That is the fundamental theorem of algebra. And the application for this one, f is analytic for the maximum modulus principle. F is analytic on the unit disk d equal to z such that mod z less than 1. இதுக்கு என்ன அர்த்தம் அப்படின்னு பார்த்தீங்கன்னா, that is mod z less than 1ன்றது that is the unit circle, that is only the region. Only the boundary irukadu. I thought so this is the only unit circle. So that is a collection of the point only on the inside of the boundary, that is the disk. Function is analytic on the unit disk, that is mod z less than 1, and continues on its closure. Continues on the closure. So suppose mod of f of z less than or equal to 1 on the boundary, mod z equal to 1, and f of 0 equal to 0, f of 0 equal to 0, then the modulus of f of z less than or equal to mod z, less than or equal to mod z for all z belongs to t, for all z belongs to t. So that is a important example, that is a g of z. When you consider the f of z by z, that is defined for the z is not equal to 0, g of 0 equal to, that is f dash of 0, g of 0 when you define for z is not equal to 0, this is the function. So g of z define that f of z by z for the z not equal to 0, and for the z equal to 0, that is called the f dash of 0. So g is analytic, okay, because of f is analytic on d, so g is analytic on d, and mod z equal to r, that is called the less than 1. By the maximum modulus principle, when you apply to the g, the function g on mod z less than or equal to r, so modulus of g of z is less than or equal to maximum of the mod of g of z, that is attained only on the boundary of the mod z equal to r, that is mod z equal to r. So the maximum mod z equal to r, that is mod of f of z divided by r, mod z equal to r என்றதுனால r, that is less than or equal to mod of f of z is less than or equal to 1, so less than or equal to 1 by r. So then when r is approaches to 1, r is tends to 1 minus, that is mod of g of z less than or equal to 1. So mod of g of z less than or equal to 1 na, this is f of z by z. So f of z by z less than or equal to 1, so that is equal to mod of f of z less than or equal to mod f of z, mod z. Okay, that is a very important result. CSIR NET like கேட்டிருப்பாங்க. And the application of Liouville's theorem பார்த்தீங்கன்னா f is entire and the real part of f of z less than or equal to m. Real part of f of z less than or equal to m. That means the real part of f of z is bounded for all z. Then f is constant. Then f is constant. That is g of z equal to e power f of z எடுக்கலாம். When you consider the g of z equal to e power f of z, modulus of g of z, that is called e power real part of f of z. So then this is less than or equal to e power m, because of real part of f of z is less than or equal to m னு கொடுத்ததனால. So from this, what is the conclusion? G of z is bounded னு வருது, e power less than or equal to e power m. So g is bounded and entire. Okay, because of f is entire, so g power f of z is the entire function, so that is analytic everywhere. So by Liouville's theorem என்ன சொல்லுதுன்னா g is constant, so g is constant சொல்லுது. That means f of z equal to what is that? F of z, when you define like that, f of z equal to log of g of z இல்லையா? So that is log c plus 2k pi I for some constant c and integer k, therefore f is constant, therefore f is constant. So because of g is constant that is considered the c. Okay, so c na there is some constant, g is constant some constant to c, e power f of z equal to c, then f of z equal to log c plus 2k pi I, very early பார்த்திருக்கோம். So for some constant c, integer k, therefore f is should be constant. That is also very important result, very important example. And a maximum modulus principle பார்த்தீங்கன்னா, that is if f is analytic and non-zero, f is analytic and non-zero in the domain D, and modulus of f of z cannot attain a minimum in D. Modulus of f of z cannot attain a minimum in D unless f is constant. ஒரு ஃபங்க்ஷன் வந்து அனாலிட்டிக்காக இருக்குது அண்ட் நான்-ஜீரோவாக இருக்குது இந்த டொமைன் டினா, modulus of f of zன்றது cannot attain a minimum. Okay, unless f is constant or that is modulus of f cannot attain a minimum, that is. So function is analytic and non-zero. 1 by f is also analytic in D. So because of f is non-zero, so when you apply the maximum modulus principle, so 1 by f times that is called the maximum. So that is f is constant and this is possible. Okay, the fragment's length of principle, that is called the f is analytic in a sector and continues on its boundary, and is continues on the boundary. Modulus of f of z less than or equal to m on the boundary. So modulus of f of z less than or equal to a e power b mod z power k in the sector. Then mod f of z less than or equal to m throughout the sector, Let us leave it. So this is the proof that f is analytic on mod z less than 1, modulus of f of z less than or equal to 1. Then modulus of f dash of 0, what is that? F of z, f is entire, and modulus of f of z less than or equal to a mod z power n, a into mod z power n for large mod z. Then f is polynomial of the degree at most n, polynomial of degree at most n, and maximum of mod z square plus 1 on the unit disk mod z less than or equal to 1. What is the maximum value? So the third problem like that 12th standard book la irukku nenikiren, I thought. Okay, so f is analytic on the mod z less than 1. So mod f of z less than or equal to 1. So I'll try to prove the mod of f dash of 0. So that is the Cauchy integral formula and R squared's lemma. So that is f is analytic on the unit disk. The Cauchy integral formula, that is f dash of 0 equal to what is that? 1 by 2 pi I integral some contour, that is f of z divided by z square dz. Ilya. So the CR is the circle, that is mod z equal to R. R is lies between the 0 to 1. So how to find the mod of f dash of 0? So modulus of f dash of 0, that is modulus எடுத்தீங்கன்னா the less than or equal to integral of the modulus. So mod of f of z less than or equal to 1, and mod z equal to R. So when you substitute here 1 by R square, so only mod dz, that is dz over the contour, that is என்ன வரும் z னு வரும், that is contour and over that it's nothing but the length, that means length of the CR and that is called the 2 pi R இல்லையா? So that means contour, that is called the 2 pi R. Mod z equal to R என்றதுனால the length வந்து it's a circle of radius R na, circle of radius R னுடைய circumference is called the 2 pi R. So when you simplify it, that is equivalent to 1 by R. Okay, So the inequality is true for all r is less than 0 to 1. So when you take the limit r is tends to 1 minus, that is called the mod of f dash of 0 is less than or equal to 1. This is one of the important problem. So when you apply the mean value property, so that is summation f of z equal to summation a n z power n. So a n equal to f power nth derivative at the point 0 divided by n factorial. So f dash of 0 equal to a1. So the Cauchy inequality, that is called um, mod of an maximum of mod z equal to r f of z divided by r power n ன்னு வந்துரும். So that's mod z equal to r என்றதனால், that is less than or equal to 1 by r power n. So for n equal to 1 க்கு a1 is the less than or equal to 1 by r. R tends to, that is 1 minus, that is mod of f dash of 0 less than or equal to 1. Okay, இதை விட the first one is best இருக்கும், that is the bound of mod of f dash of 0 less than or equal to 1. When you consider the function f of z equal to z, then mod z less than 1 and f of z less equal to mod z is less than 1 for mod z less than 1. So f dash of 0 is equal to 1 ஆயிடும், that is a mod of f dash of 0 equal to 1. இதை விட the first type is best one. That when you use the Cauchy integral formula, the best choice. This is another problem. So a mod of f of z, f is entire, and mod of f of z என்றது less than or equal to a times mod z power n. Okay, a times capital A times mod z power n for large mod z. இங்க வந்து large mod z னா mod z greater than r naught, like that is like that. So that is the, we want to prove that f is a polynomial of degree at most n. F is a polynomials of degree at most n. So this is the application of the Liouville's theorem, that is extended to the function with the polynomial growth. So the f is the entire and it has the Taylor series expansion about the z equal to 0, that is converges for all z, that is f of z equal to ak z power k. ak என்றது இப்ப பார்த்தோமே, that is fk, that is kth derivative at the point 0 divided by k factorial, that is the Taylor series. So the Cauchy estimate பார்த்தீங்கன்னா mod of ak என்றது இங்க mod of maximum of mod z equal to r, that is mod of f of z divided by r power k இல்லையா. So that mod f of z less than or equal to a z power n. So mod z greater than r, so இது என்ன ஆகும், a into r power n divided by r power k ன்னு வரும். So r power n minus k ன்னு வந்துரும். So that is, so therefore k greater than n இருந்ததுன்னா, that is n minus k less than 0 இருக்கும். n minus k less than 0 இருந்தா r is approaches to infinity, r power n minus k approaches to 0. So mod of ak less than or equal to a r power n minus k for all sufficiently large r, that is mod of ak equal to 0. Therefore ak equal to 0 for k greater than n. Suppose k less than or equal to n இருந்தா, that is approaches to mod of ak a r power n minus k, which is grows as r turns to infinity if k is less than n or remains constant, that is if k equal to n. So that is ak doesn't force ak to be 0. ak is not converges to 0. So therefore the coefficient ak for with k greater than n, this is r0. Therefore the power series f, therefore f of z equal to summation ak z power k, which is a polynomial of degree at most n, at most n, exactly degree n, if an is not equal to 0. So that is extended Liouville's theorem, that is f is the entire and satisfy the mod of f of z less than or equal to a plus b z power k for some constant a comma p greater than 0, integer k greater than or equal to 0. So then f is a polynomial of degree at most k. F is a polynomial of degree at most k. This is called the extended Liouville's theorem. So that means the given condition mod f of z less than or equal to a z power n for large mod z. So mod f of z less than or equal to a z power n plus c for some constant c. By the extended Liouville's theorem, f is polynomial of degree at most n. That is the statement. Okay, the statement apply பண்ணி டைரக்டா ப்ரூவ் பண்ணலாம். And another problem பார்த்தீங்கன்னா f of z equal to another type, that is f of z equal to z power n, that is mod f of z z power mod z power n. So f is a polynomial of degree exactly n. That is another problem, that is a maximum on unit disk, that is the maximum of the mod of z square plus 1 on the unit disk mod z less than or equal to 1. So when you apply the max modulus principle, so f is analytic and continues on the closure, the maximum mod f of z on the boundary, that is closure, occurs on the boundary. So z square plus 1 is the entire analytic everywhere. So the particular its analytic mod is less than 1 and continues on the boundary. So the maximum occurs only on the boundary. Then on mod is less than or equal to 1 occurs. So on the boundary mod is equal to 1. Mod is equal to 1. And that is e is equal to e power I theta mod is equal to 1 and e power I theta, that is modulus of the, when you apply the Euler's formula, so then we get it 2 into mod of cos theta, that is 1. That is always maximum occurs only on the boundary. So at z equal to 1, what is the value? So mod of z square plus 1, that is less than or equal to mod z square plus 1. That is mod z is only on the boundary, that is 1, that is maximum value is 2. Only on the boundary z equal to 1 and minus 1. So that is the best, otherwise leave it. This is the boundary, the maximum value occurs only on the boundary, that is the maximum model. So that is value is 2. Okay. So this is the Cauchy essential for the bounding derivatives. Taylor coefficient is analytic. Maximum models are powerful to find the maximum for the analytic functions on the bounded domains. Liouville's theorem and extension fundamental characterize the entire function with the growth restriction, useful technique for the optimization function, optimizing the function that is maximized on a circles and other simple curves. That is called the squads lemma, that is fb analytic on mod z less than 1, f of 0 equal to 0, mod of f of z less than or equal to 1, so mod of f of z less than or equal to mod z, mod of f dash of 0 is less than or equal to mod 1. Under the condition function is analytic, f of 0 equal to 0, mod of f of z less than or equal to 1 and mod of f of z less than or equal to mod z, mod of f dash of 0 less than or equal to 1. The result of the very important one. And the function is analytic and annulus region and continues on its closure. If mod f of z less than or equal to 3 on mod z equal to 1, mod f of z less than or equal to 12 on mod z equal to 2, then mod of f of z less than or equal to 3 times mod z square and the annulus. அதே மாதிரி f is the entire f of z plus 1 equal to f of z for all z now, and the period 1, that means period is 1 in artham, function period is 1. F is bounded in the strip 0 less than equal to real part of z less than equal to 1. So then f is constant. Okay, third one is very important. The first one பார்த்தீங்கன்னா, that is f is analytic on mod z equal to mod z less than 1, f of 0 equal to 0, mod f of z less than or equal to 1. So already I'm போட்ட மாதிரி, that is so that is modulus principle, max modulus principles, that is f of 0 equal to 0. So we can write the function f of z equal to z into g of z, because of f of 0 equal to 0. G of z is analytic on mod z less than 1. So therefore so f of z equal to f of 0 plus f dash of 0 into z, that is z by 1 factorial, that is the Taylor series, that is z times f dash of 0 plus something equal to f of 0 equal to 0, so that is z times something equal to This is called the g of z. This is called the g of z. Am I correct? So because of f is analytic, g of z equal to f of z by z. For the z is not equal to 0, g of 0 equal to, that is limit z tends to 0 f of z by z. That's nothing but f dash of 0. By the definition of this is nothing but limit z tends to 0 f of z minus f of 0 divided by z minus 0. So because of f of 0 equal to 0, this is the derivative at the point 0, that is f dash of 0. So g dash of g is analytic and mod is equal to 1. So already நாம் argue பண்ண மாதிரி தான், that is r is slice பண்ணி the 0 to 1. Already இந்த function வச்சு போட்டிருக்கோம். The same argument பண்ணீங்கன்னா mod of g of z less than or equal to 1 by r னு வந்துரும் when you apply the max modulus principle. So mod z less than or equal to r. Here consider the r is slice between the 0 to 1, the mod z less than or equal to r. So then for any fixed z mod z less than 1, choose r. r என்றது mod z less than or less than 1 choose பண்ணி mod of g of z less than or equal to 1 by r. r is approaches to 1 now, mod of g of z less than or equal to 1 is we get it, the mod of f of z is mod z into mod of g of z, that is called mod of g of z less than or equal to 1 ன்னு தெரியும். So mod of f of z less than or equal to mod z ன்னு வந்துரும். So the derivative is bounded, mod of g of 0 equal to f dash of 0. So mod of g of z less than or equal to 1, mod z less than 1 னா அப்பனா mod of g of 0 less than 1, அப்பனா mod of f dash of 0 is less than or equal to 1. So these are result. நீங்க ரிசல்ட்டா ஞாபகம் வச்சுட்டாலும் okay, that is better. I thought that is best, the first method. And the next problem, f is analytic and annulus. F is analytic and the annulus region 1 less than mod z less than 2. That means this is the radius 2 lower circle, this is the radius 1 lower circle. There's an annulus region, the function is analytic and it continues on its closure. And mod f of z less than equal to 3 on mod z equal to 1, mod f of z less than equal to 12 on mod z equal to 2. Under this condition, mod f of z less than or equal to 3 times mod z square on the annulus ன்னு சொல்லணும். So that is the problem. So A என்றது, that is the some domain, that is closed annulus. Function is analytic 1 less than mod z less than 2 and continues on the boundary. இல்லையா? Mod f of z less than equal to 3. Mod f of z less than equal to 3 on the inner boundary, mod z equal to 1, and mod f of z less than equal to 12 and the outer boundary mod z equal to 2. Want to show that this one. So 3 times mod z square equals to 3 when mod z equal to 1. That is okay. Mod z square. So 3 times, that is when mod z equal to 2, then that 4 into 3, that is equal to 12. So 3 times mod z square, that is matches with the given bounds on the both boundaries. So that is called the mod f of z less than equal to the same thing. So when you consider the function g of z equal to f of z by z square, so this f is analytic, this one, and z square is analytic non-zero on the annulus region except z equal to 0. So which is not in our domain because of annulus region தான். அதனால g of z is analytic in the annulus region. So that is on the boundary mod z equal to 1, that is less than equal to 3. And mod z equal to 2, this is less than equal to 12. Okay, that is mod of g of z less than equal to 3. So mod of g of z is always less than equal to 3 on the both boundaries of the annulus. So when you apply the max modulus principle, that is a g of z is analytic and the modulus and it continues on its closure by the max modulus principle through the closed annulus 1 less than equal to maximum occur only on the boundary. இல்லையா? maximum occurs only on the boundary, so mod of g of z less than or equal to 3 on the boundary, so mod of g of z less than or equal to 3 for all z belongs to A. So then f of z, g of z less than or equal to 3 now, that is f of z 3 times mod z square, that is the idea. The same way ಇದನ್ನು generalization. Mod f of z less than or equal to m, mod z equal to r1, that is the one of the boundary. Mod f of z less than or equal to n, mod z equal to r2, that is g of z equal to f of z by z power k. So k is chosen so that m by r1 power k, that is equal to n by r1 r2 k. K equal to log of n by m divided by log of r2 by k. So g of z less than or equal to m by r1 k on the boundary, both boundaries. So that is m times mod z power k divided by r1 power k on the annulus mod of f of z. And also f is entire and f of z plus 1 equal to f of z for all z period 1. F is bounded in the strip period 1 function entire, and the function is bounded on the strip 0 less than x less than 1. Real part of z enter, that is called the x is sliced between the 0 to 1 and all. Then f is constant. Result okay. So then f is periodic with period 1, and consider the function g of w equal to f of log w divided by 2 pi I. So then it's a periodic function, and also the function strip is real part of z less than or equal to 1. So then f of x plus iy and the of the function x is periodic with period 1. So the Fourier series f of x plus iy equal to like that. So that is so modulus of Cn is it's bounded by mod of f of z. F is bounded on the strip, so that is less than or equal to m, that is real part of z less than or equal to 1. So mod of Cn rather something vandrum. So y is approaches to minus infinity, it's become the 0. Y is approaches to plus infinity, for the n less than 0 this is equal to 0. So Cn equal to 0 for all n not equal to 0, so f of z equal to constant. So define the auxiliary function for the when you apply the Liouville's theorem. So g of z equal to f of z minus f of 0. So h of z equal to g of z divided by sine of pi of z. Sine pi z as zeros. So that is considered boundedness of the horizontal lines. F is bounded on the strip, and mod of f of z less than or equal to n in the strip. The periodicity f is bounded on the every horizontal strip. So by the same bound m. So f is bounded on the every horizontal line, that is imaginary part of z equal to y by m. So the consider the function capital f of z equal to something. Capital A equal to supremum of mod f of x now. F of capital F of x plus iy less than or equal to a for all x and y. So the argument that is f is bounded on the strip, so m equal to supremum of the mod f of z. So mod of f of z equal to mod of f of x plus y less than or equal to n. So f is bounded on the complex domain. So when you apply the Liouville's theorem, f is entire and is bounded, therefore the function is constant. So this is the conclusion, that is for the squares lemma. For the squares lemma trick, g of z equal to f of z by z, f of 0 equal to 0, and when f of 0 equal to 0, endless problem, that is the g of z equal to f of z by z power k, and periodic entire function, that is periodic related to the outside of the strip values inside the apply the Liouville's theorem. Maximum modulus means the estimation of the problem, and Liouville's theorem that the entire functions are constant under the bounded condition. So that is the power series. Power series, a power series centered at Z0. Power series centered at Z0 and is an infinite series of the form summation a n z minus z0 whole power n. This is the general form of the power series. A n belongs to C or coefficients and Z belongs to C. And circle of convergence, that is of the power series, is the circle centered at Z0 and with the largest radius capital R. Largest radius is the capital R, such that the series converges mod of Z minus Z0 less than R. That is very important. That is converges mod of Z minus Z0 less than or equal to R. And it diverges for mod of Z minus Z0 less than greater than R. It diverges for all mod of Z minus Z0 greater than R. This capital R is called the radius of convergence. This capital R is called the radius of convergence. So the absolute convergence inside the circles, so that is the power series வந்து பாத்தீங்கன்னா an z minus z0 whole power n, that is converges z equal to z1, z1 not equal to z0. Okay, that means inside in artham. Then it's absolute convergent at each point z in the open disk mod of z minus z0 less than r1. That's r1 should be length z1 and z0 should be equal. R1 equal to z1 minus z0 is equal. Okay, that is the absolute convergence theorem. And consider the geometry series summation z power n. This converges at z equal to 1 by 2. Mod of 1 by 2, that is equal to 0.5. So it converges absolutely mod z less than 0.5. Mod z less than 0.5. Okay, therefore its converges mod z less than 1. Therefore its converges mod z less than 1. That is the circle of convergence. So the greatest circle center at z0 such that the series converges at each point inside the inside is called the circle of convergence of the series. The series cannot converge, the power series cannot converge at any point z2 outside the circle. So that is, it converges everywhere inside the circle center at z0 passing through the z2, and the first circle, that is the circle of convergence. Uniform convergence on the z1 is the point inside the circle of convergence of the power series. Then the series must uniformly convergent in the closed disk mod of z minus z0 less than or equal to r1. R1 is equal to mod of z1 minus z0. And z power n divided by n factorial. Consider summation n equal to 0 to infinity z power n divided by n factorial, that is the exponential series. Z power 0 by 1, 0 factorial, that is 1 plus z by 1 factorial, z square by 2 factorial, like that. This as the radius of convergence r equal to infinity. So the radius of convergence of the exponential series r equal to infinity. For any r1 greater than 0, the series converges uniformly mod z less than or equal to r1. Mod z less than or equal to r1. This is the center and radius r1, and mod of z minus z0 equal to r. This is the r1. This is the r. Radius is r. The shaded region, this is called the convergent. A power series summation a n z minus z0 whole power n represent the continuous function, that is s of z, at each point inside its circle of convergence. This is the continuous function. The power series represent a continuous function s of z at each point inside its circle of convergence, mod of z minus z not equal to r. So the summation z power n, the geometry series 1 by 1 minus z mod z less than 1. This function is continuous on mod z less than 1, even though it has the singularity at z equal to 1. That is very important. And the sum s of z of the power series, this power series, is analytic at each point z interior to the circle of convergence of that series. So this is the term by term integration of that C denote the any contour integral, a contour interior to the circle of convergence of the power series, summation a n z minus z and whole power n. G of z be any function that is continuous on C. The series formed by the multiplying the each term of the power series by G of z can be integrated term by term over C. So that is integral C G of z s of z dz. Summation a n integral C G of z z minus z naught whole power n dz. So this is the exponential function as the radius of convergence r equal to infinity. So by the ratio test we can apply the ratio test, that is a n equal to 1 by n factorial. So it is converges absolutely for all z belongs to C, converges uniformly mod z less than equal to r1, and sum e power z is continuous and analytic on all C, and differentiated term by term, that is called differentiate term by term, that is also equivalent to e power z. And the geometry series summation z power n as a radius of convergence r equal to 1. So this is converges absolutely mod z equal to 1, mod z less than 1, and uniformly converges mod z less than equal to r is less than 1. That is very important. And sum is 1 by 1 minus z, that is 1 plus z square. உங்களுக்கு அந்த சீரிஸ் தெரிஞ்சதுனாவே that is sum is தெரியும். 1 plus z square plus and so on. This is converges to 1 by 1 minus z, that's nothing but the 1 minus z whole power minus 1. So that is sum is 1 by 1 minus z for mod z less than 1. And a term by term integration, that is integral 0 to z 1 by z dz, that is zeta, that is summation n equal to 0 to 0 to z zeta power n dz, that is equal to summation z power n plus 1 divided by n plus 1. The same way logarithm series 1 by 1 plus z, that is a logarithm series, that is 1 by 1 plus z equal to summation n equal to 0 to infinity minus 1 power n z power n mod z less than 1. Integrating term by term by z equal to 0 to z, log of 1 plus z equal to summation minus 1 power n z power n plus 1 divided by n plus 1, or minus 1 power n minus 1 z power n by n mod z less than 1. The series has a radius of convergence, that is r equal to 1. Okay. So the radius of convergence for this one, that is just using the ratio test, that is n plus 1 factorial divided by limit n tends infinity, that is an plus 1 divided by an. Apply pannanga, that is n plus 1 into mod z, that is as n tends infinity it's become the infinity, that is called the for z is not equal to 0. Therefore 1 by r is called the this value is equivalent to the 1 by r. So the radius of convergence is 0. Radius of convergence is equal to 0. The same way this is nth root of an, that is limit n tends infinity, this is equal to z power n divided by n power n, that is equal to whole power 1 by n, that is z by n and vandrum. As n tends infinity this is equal to 0, this is equivalent to 1 by r. So radius of convergence is r equal to infinity. So 1 by 2 power n, the ratio test, this is equal to 1 by r equal to limit n tends infinity, that is z minus 1 whole power n plus 1 2 power n plus 1, when you simplify it mod of z minus 1 divided by 2. So the series is converges, this is less than 1. After mod of z minus 1 less than 2 na, the series is converges. So then r equal to radius equal to 2. Radius of convergence is 2. So mod z less than or equal to 1, z power n divided by n square, that is less than or equal to 1 by n square. Summation 1 by n square is a converges. Weierstrass test the summation z power n divided by n square uniformly converges on mod z less than 1. The same way z by 2 power n, that is geometry series, the ratio on the z by 2 the converges when mod z by 2 less than 1. The modulus port, that is less than 1, that is convergence, that is mod z less than 2, the series is convergence, that is r equal to radius of convergence 2. Okay, so the node derivative and term by term differentiation. There is a Taylor series representation theorem, that is summation a n z minus z naught whole power n, that is converges to f of z at all points interior to the some circle mod of z minus z naught equal to r. Then it is the Taylor series expansion of for f in the power series z minus z naught. So the f cover kth derivative, so a k equal to something. But earlier நம்ம இதான் யூஸ் பண்ண டைரக்டா. The uniqueness of the power series representation, if a function f has the power series representation center at z naught, the representation is unique and must be the Taylor series. And Taylor series f about the z naught converges to f of z at each point z interior to the circle center at z naught passing through the nearest point of z1 where f fails to be analytic. There is no larger circle about the z naught at each point z interior to its Taylor series converges to f of z. So if there were some such a circle, that is f is analytic at the point z1, so but f is not analytic at the point z1. This is the term by term differentiation. So this is the entire extension function, extension of sin z by z. So this is the function sin z by z, z is not equal to 0, z equal to 0 is 1. So this is the entire function, that is analytic everywhere. So when I expand it, this is, so the power series converges everywhere and represent an entire function, that is called this entire. And sin z by z is a removable singularity at the point z equal to 0. Okay, that is f of 0 equal to 1, remove the singularity. Exponential function already discussed on it. This is the function, the series summation a n z power n equal to 0 for all z in the disk mod z less than or, then a n equal to 0 for all n. So this is the some problem like that, the series, power series. So then a n equal to, that is a j cube z power j, so a j equal to z cube, then the 1 by r equal to, that is called a j an plus 1 divided by an ratio test. So இது apply பண்ணீங்கன்னா that is called j plus 1 whole cube, that is 1 plus j plus 1 whole cube divided by j cube னா இதை simply பண்ணீங்கன்னா limit j tends to infinity 1 plus 1 by j whole cube into mod j. As j tends to infinity, it's become the mod z. அப்படின்னா by the ratio test the series converges mod z less than 1, diverges for the mod z greater than 1 இல்லையா? So that j cube z power j, that is called cube root of jth root, that is nth root ன்னு போடுவோம், that is jth root of j cube mod z j. So that is called this has become the 1, that is mod z. எந்த டெஸ்ட்ல root test apply பண்ணீங்களோ that is the radius of convergence is 1. Circle of convergence is called the mod z equal to 1, center 0 and the radius equal to 1. So the 2 power k z minus 1 whole power k, this is called that geometry series r equal to 2 into z minus 1, r equal to 2 into ரெண்டுமே power k தான் இருக்கு. So this is a geometry series. ஒரு geometry series converges mod r less than 1, அவ்வளோதான் converge ஆகும். இது ஒரு geometry series, ரெண்டுமே power same power. So that is geometry series converges when mod r less than 1, very earlier பார்த்தோம். So இங்கே பார்த்தீங்கன்னா mod of 2 into z minus 1 less than 1. Now mod of z minus 1 less than 1 by 2 la the series is the converges. So the radius of convergence is 1 by 2. So circle of convergence mod of z minus 1 equal to 1 by 2. Am I correct? So the same way j factorial into z power j. So j factorial into z power j, na, that's best option, that is ratio test. So that is limit is approaches to j tends to infinity, z equal to 0 na, that is 0, z is not equal to 0 na, it's become the infinity. So the series converges only at z equal to 0. So the radius of convergence is equal to 0, and circular convergence degenerate circle, that is just the point z equal to 0. The point z equal to 0 is called the circular convergence. Okay. Direct that is that 1 by r, this is equal to 1 by r. As j tends to infinity, it's become the infinity. So that r equal to the radius of convergence is 0. Okay. minus 1 power k divided by 3 power k into k. இதில் என்ன பண்ணியிருக்கோம், ரேஷியோ டெஸ்ட் தான் அப்ளை பண்ணியிருக்கோம். ஸோ தென் when you simplify it, இந்த சிம்பிளி பண்ண தெரியணும். ஸோ இதை கேன்சல் பண்ணிவிட்டு சிம்பிளி பண்ணிங்கன்னா z மைனஸ் i 1 தான் வரும். இதை மட்டும் கொஞ்சம் கேர்ஃபுல்லாக சிம்பிளி பண்ணணும். மாடல்ஸ்ன்றதெல்லாம் minus 1 power something is 1 தான், ப்ளஸ் 1 தான். ஸோ உங்களுக்கு கிடைக்கிற அவுட்புட் இது தான். இதில் லிமிட் k tends to infinity நம்ம போடும் பொழுது ஓகேவா, தென் த ப்ராப்ளம் இஸ் பிகம் 1 plus 1 by k. 1 plus 1 by k என்றது 1 ஆகிடும், 1 into 1 by 3. ஸோ 1 by 3 into z minus i வரும் as k tends to infinity போட்டிங்கன்னா. ஸோ இது வந்து less than 1 இருந்தால் the series is converges. அப்படின்னா less than 1 போட்டிங்கன்னா mod of z minus i என்றது less than 3 வருது. அப்படின்னா radius of convergence is 3 and circle of convergence mod of z minus i equal to 3. So that is a very important one. Okay. The 3 minus i whole power k, the same type of problem. Okay. இங்கே பார்த்தீங்கன்னா இதை சிம்பிளி பண்ணும் பொழுது mod of z plus 2, that's equivalent to root 10 வருது. So mod of 3 minus i is the root 10. So root 10 into z plus 2 வருது. So that is less than 1 the series is the convergence. அப்படின்னா radius of convergence is the 1 by root 10 and circular convergence mod of z plus 2 equal to 1 by root 10. Okay. That is same way z power 2j 4 power j, z power 2j divided by 4 power j. So that is z square equal to omega ன்னு வைக்கும்போது omega power j divided by 4 power j. This has become the geometry series. Geometry series என்றது அப்படியே போட்டுடலாம், that is omega power 4 less than 1 னா the series is converges. அப்படின்னா that is called the omega power 4 less than 1 ன்றது mod z square less than 1. Now mod z less than root 4. Root 4 into the 2. Mod z less than 2 na the series is converges. Now that is called the ratio test. That is the radius of convergence is 2. The same way aj equal to 1 by 4 power j. Then it's become like that. எப்படி போட்டிங்கனாலும் radius of convergence is 2 தான். Circular convergence mod is equal to 2. That first method is the best one. Is the problem. Okay. So this is the formula. Ratio test limit to supremum of n root of n, that is called that 1 by r நம்ம கண்டுபிடிப்போம். 1 by r equal to limit n tends infinity an plus 1 divided by an, and 1 by r equal to limit n tends infinity nth root of an. This is the formula. Radius of convergence கண்டுபிடிக்கிறது. This is some other problems, and so 1 by r equal to 0 vandana, that is converges, series converges for all z னு அர்த்தம். That is r equal to radius of convergence is infinity னு அர்த்தம். Okay, that is some other problems, that's all. So இது மாதிரி வந்தனா, that is mod z less than 1 ல the series is converges, that is radius of convergence. So 1 plus 1 by n. இது மாதிரி பவர் வந்ததுன்னா, that is called root test apply பண்றது best. இது மாதிரி பவர் whole power n like that, இது மாதிரி வந்ததுன்னா root test best. root test apply பண்ணும்போது, that is limit n tends infinity mod z. So this is limit n tends infinity mod z less than 1 na the series converges, so radius of convergence is 1. mod z greater than 1 na diverges. Okay, so the power series is very important. Particularly the problem கேக்கிறதுக்கு நிறைய வாய்ப்பு இருக்கு power seriesல ரிசல்ட்டை விட. So 1 by n power n, that is the radius of convergence, like that, the same way is infinity. So இது geometry series. Geometry series na mod z less than 1 is the radius of convergence, that is the radius of convergence is 1. So this is mod z equal to 1. Let's leave it. நீங்க நார்மலா போடுற மாதிரி போடுங்க, that is the radius of convergence and geometry series converge பண்றதுக்கு. Like that, does there exist a power series summation aj z power j that converge at z equal to 3 plus I, diverge at z equal to 3 minus I. So that is z1 z2 னு எடுத்தீங்கன்னா, mod of z1, that is this one, mod of z2 root 10, mod of z2ன்றது less than mod z1 இருக்கு. So the power series converge at z1, then by the radius of convergence theorem it converge absolutely for all z mod z less than 1 இல்லையா? So mod z2 less than mod z1, mod z2 less than mod z1 என்றதுனால the series converges at z1, it must also converge at z2. So therefore there cannot exist such a power series. The power series that converge at z1 must converge for all z mod z less than root of that. Okay, this is some other problem. வீட்டில் பாருங்க, and power 6th 0. That is from the Taylor series, the coefficients f power n to 0, that is called the n factorial an. An is the coefficient of z power n. So ak equal to something கொடுத்திருக்காங்க. So a power 6 0 னா a6 கண்டுபிடிக்கணும். That is called the 6 cube divided by 3 power 6, that is equal to a big 27. Sixth derivative at the point 0 into the 6 factorial a6, that is the answer. Okay. And the Cauchy integral formula when you apply for this one, f power nth derivative of 0 divided by n factorial equal to the something இல்லையா, this is the formula. So this is equal to integral c mod z equal to 1 2 pi I by 3 factorial into derivative of 3, okay, at the point that derivative at the point 0. So that is the function. உங்களுக்கு தெரியும் function எடுத்துட்டு we get the result. This is some other problems. The problem எல்லாம் கொஞ்சம் ஈஸியாக தான் இருக்கும். We'll try. Mostly the power series and வர ப்ராப்ளத்தை பார்த்துங்க. These are some series, Maclaurin series for this one. At the point z equal to 0, Taylor series is called the Maclaurin series. இது மாதிரி கேட்டாங்கன்னா f power 3 0 and f power 4 0 ஒரு சீரிஸ் கொடுத்துட்டு is f power n Taylor series தேர்தா அப்ளை பண்ணலாம். f power n 0 equal to n factorial an, அதை முன்னாடி யூஸ் பண்ணி ப்ராப்ளம் போட்டோம். ஓகே. ஓகே. ஸோ பாருங்கள் கொஞ்சம் தயவுசெய்து, அண்ட் எது டவுட்னா கேளுங்க. ஓகே, தேங்க்யூ.